got it here somewhere. Angle relationships. Keep your pencil out and get them sharpened up and get ready to write here. Definitions here. First definition we're going to go over is what is an adjacent angle. Adjacent. And you probably know what adjacent means. Somebody is sitting next or adjacent to you, they're sitting next to you. An adjacent angle are two angles that share a common side, or a common ray, or whatever you want to call it. If you're looking at my handy dandy little thing here, there are numerous adjacent angles here. Okay, angle 2 is adjacent to angle 1. Why? Because they share this side right there. Angle 2 is also adjacent to another angle, which is angle 4. And get it? They're right next to each other. That's what adjacent means. And you got 4 is adjacent to 3, 4 is adjacent to 2. 1 is definitely not adjacent to number 4 because it does not share anything with number 4. That's what makes it the next thing, what we call opposite angles. Opposite angles, by the way, these are when you have two intersecting lines. And those angles share the same vertex but do not share a side. Do not share a side. Okay, so there's only a couple of these. Angle 1 is opposite of angle 4, and angle 2 is opposite angle 3. Opposites. They don't have any sides in common. They do have what we call a common vertex. And in addition to that, just to mucky the water just a little bit more, okay, opposite angles are also called vertical angles. A, K, A. Opposite and vertical mean the same exact thing. Now, in addition to that, a couple of facts that you need to know about these things here are that opposite angles are equal. Opposite angles are equal. If angle 4 here equals 120 degrees, then so does angle 1. And then we should put down there, as far as adjacent angles go, if you have two intersecting lines, what do you know about adjacent angles? In other words, what could you tell me about angle 1 and angle 2 here? What little fact holds true there? Which would be the same thing if you talked about angle 4 and angle 3 being adjacent. What do you know about them? Are they equal? Do they look to be equal? They are not. Angle 1 definitely is not equal to angle 2. And angle 3 is definitely not equal to that. But there is something true about them. If you put them together, what do you get? You get a straight line. Adjacent angles put together, which they already are, give you a straight line. And that little fact, ladies and gentlemen, is what we call being supplementary. A-R-Y or E-R-Y? Anybody? A-R-Y, good. Supplementary angles add up to 180 degrees, which is a straight line. So since I know that angle 4 and angle 1 are 120 degrees, you may be able to tell me what angle 3 and angle 2 are, because these two, 1 and 2, are supplementary, which means they form a straight line, which means they give 180 degrees. So angle 2, Cameron Colquitt, has to be, right? 120 plus what is 180?
Oh, it meant something.
One more shot. 60 degrees. 60 degrees is correct. Okay. So with all this gobbledygook, you need to know what a supplementary angle is. You need to know what adjacent angles, opposite, and vertical angles are. One other word that doesn't come into play right here, what we need to know, is that we have supplementary angles and we have complementary angles. Anybody know what a complement is? Complementary angles are two angles that add up to 90 degrees, or they make a right angle. Make a right angle. And the way that I keep complementary and supplementary kind of straight, because they both kind of mean the same thing but different, add up to different numbers. Supplement, when I think of supplementary, I think of super. Supplementary is the bigger one, supersized. Okay, supplementary add up to 180 degrees. Complementary angles add up to 90 degrees. These two angles here would be complementary because they add up to a square corner. Sometimes the book will ask you, what's the complement of 40 degrees? What is the complement of 40 degrees? All they're asking you for is what angle, when you add it to 40 degrees, will give you a 90 degree angle. The complement of 40 degrees is 50 degrees. What would the supplement of 40 degrees be? The supplement, sup of 40 degrees is just asking you what angle added to 40 degrees gives you a straight line. That would be M?
I was going to say, can I go to
Sure. What two angles, what would you add to 40 degrees, Riley?
140.
140 degrees. That would be the supplement of that. Now, how does that come to play? Write down this problem. Draw this on the bottom of that or somewhere where you have a little paper there. Right out of the book. We got this, we got this. We got a little square corner there. We've got this. You'll probably see this on a map someplace or some point. 1, 2, 3, and 4. 1, 2, 3, 4. And I know this is 40 degrees. Knowing that this angle here is 40 degrees, I can figure out every other angle on this little rectangle, triangle thing based on what we just talked about. Alright, and maybe you can tell me why, maybe you can't. For example, I know that angle 1 has to be how many degrees and why? How many degrees does angle number 1 have to be, Lainey?
140 degrees.
140 degrees, why? Now you gotta use some math jargon here. Yep, because it's a supplement of the 40 degree angle. forms a straight line, so 40 degrees plus what gives you a straight line. Angle 2, ladies and gentlemen, have to be how many degrees? You can give me 2 reasons for this one. 2 reasons. Isabel, angle 2 has to be
40 degrees.
why?
Because it's a supplementary angle of which one is a
Yep, that's one reason. Because it's supplementary to angle 1, but it also is what? One of the other things we talked about.
opposite angle.
Yeah, because it's opposite or a vertical angle of this. 2 lines cut, intersect, opposite angles are equal. So if this is 40 degrees, this has to be 40 degrees. Both of those reasons. And then angle 3 has to be how many degrees? This one's more about triangles than it is about what we just talked about, but you can figure it out. Carol, wait, go ahead.
50 degrees.
Why?
It's complementary to angle 2.
It isn't complementary. Oh, it is complementary to angle 2. Sorry, yes. Because this is a right angle, these two have to add up to the other 90 degrees. Okay, so it is complementary to angle 2. Exactly. And angle 4 would have to be how many degrees? How many degrees would angle 4 have to be in Y? Elijah Fisher?
40 degrees.
Nope, 4 has to be more than 40 degrees. Maybe I should emphasize this. How many degrees does it have to be, Brianna? 130 degrees. Why? Because it is it's supplementary to angle 3. These two form a straight line. They're supplementary, so that has to be 130 degrees. Isn't math exciting today? Now, lest you thought that was even close to being it, now we get to the real meat and potatoes. Hold on a second. I don't remember tons of things from my high school mathematical educational career, but what I'm going to talk about now is definitely one of them. And you're going to write down the phrase that phrase here. Back here. Mitch, what was your question?
I was going to say for a supplementary angle, if they add to 180 degrees, why would they get 40 here and 30?
This was 50. Okay. 50 plus what number gives you 180? 130. Is it not?
Oh, yeah, I see.
130 plus the 50 there is 180. Yeah? Did I miss you? You got it? Okay. Yeah? Sure, go talk to Mrs. Stone. Okay, this one here, ladies and gentlemen, I need you to write this down because this is the one of the things that I remember from my high school math is saying this phrase right here. So write this down in quotation marks. If two parallel lines are cut by a transversal, then it's kind of fun to say if two parallel lines are cut by a transversal. First, we have to talk about, you obviously know that these are the two parallel lines. Okay. The thing, let me get the exact out of the book here. A transversal is the third line This is the transversal. It is the line that cuts the parallel lines. Line cutting parallel lines. So here's my transversal, there's my parallel lines. Stay with me so far? Transversal is the line that is cutting the parallel lines. Okay. And then we have a whole new slew of definitions here. Okay. The first one is what's called corresponding angles. Corresponding angles. Corresponding angles, the best way that I've ever thought to tell you what corresponding angles are if you could reach your hand in and go to this intersection of angles 5, 6, 7, 8, grab that thing, pull it right off the paper, pick it straight up, lift it up and put it right over top of angle 1, 2, 3, 4. It is the angles that fall on top of each other or below each other. Okay? So I'm going to write that down as a little hint. So pick up and set over top. So if I asked you what some corresponding angles would be there, you would tell me that angle 8 right here corresponds to which angle in the other set of angles there? Pick it up, switch it over, set it down. It is going to be Jaden, angle 4. It's not a hard thing, but you might forget what it is. Now, angle 6 corresponds to angle. Angle 6 would correspond to what number there? Mitch? 2. Angle 2. Now, guess what? Guess what we're going to say about corresponding angles. What do you suppose? If you look at 8, 4, 7, 3, 5, 1, they are going to be, Keith?
They have the same
Please. We call that mean equal. There you go. Corresponding angles are equal. Corresponding angles are equal. Angle 6 equals angle 2. Angle 5 equals angle 1. Those are corresponding angles. If angle 8 was 110 degrees, then so would be angle 4. Because they are corresponding angles. Then we have this. Here's where people maybe get a little, I'm running out of flavors here. Go back to paint. We have what are called interior angles. And we have what are called exterior angles. Here is the difference. Interior angles, back to this. Interior angles are angles that fall inside the parallel lines. This is the inside of the parallel lines. Exterior angles are the angles that fall outside the parallel lines. So you got kind of interior angles kind of split apart the exterior angles. Okay, I should probably write that down. Are outside the parallel lines. And interior angles are inside the parallel lines. That's a different color. You've got your handy dandy little thing. Now, lest that wasn't confusing enough, we have what are called alternate interior angles. And we have what are called alternate exterior angles. Alternate. Now you're probably thinking in a spelling bee, an alternate is the guy that comes in last or doesn't get whatever. That's not what it necessarily means in math. If something alternates, what does that mean? If you were out there shooting baskets, Cameron, and the coach said, hey, you and Jaden alternate shooting, what does that mean? You switch, you go from one side kind of the other, or whatever you do, whatever. That's kind of what it means here. Alternate interior angles. First of all, there are 4 interior angles. You have 3, 4, 5, and 6. Those are all interior angles. Alternate interior angles are the interior angles that fall opposite of the one on the bottom. Angle 3 and angle 6 are what we call alternate interior angles because you flip from one side of the transversal to the other side. So you've got, for alternate interior angles, you just have 2 sets of them. You have angle 3 is an alternate interior to angle 6, and angle 5 is an alternate interior to angle 4.
Wait, so is it just like,
It's like opposite side, but it's also interior. Same thing is true for the exterior ones. Alternate exterior means the same thing. You've got 4 exterior angles, angle 1, 2, 7, and 8. Angle 8 is an alternate exterior to angle 1. You have to go to the other side of the transversal. Okay, so angle 1 is an alternate exterior to angle 8, as is angle 7 alternate exterior to angle 2. Now, guess what we're going to say about those angles? Alternate interior and alternate exterior angles are, if you look at angle 8, by the way, let's do some of the math we already know. How many degrees is angle 5? Angle 5 is how many degrees? Because it is it's a vertical or opposite angles. Okay. How many degrees is angle 1? 110 degrees. How many degrees would angle 6 and angle 7 be? How many degrees? Why? Somebody say yes? Because they're supplementary, right? So we know all of those angles there. What do we know then about alternate interior angles? What are they? They're the same. They're equal. These are equal. Oh, sorry. This is equal. And this is equal. All these things we're talking about are equal. Now, not all interior angles are equal, but the alternate ones are equal. 6 and 3 are equal, and 5 and 4 are equal, but they're not all equal. Just the alternate interior ones. Emily's mom is on her way. How long?
I don't know how much.
oh, 2 minutes.
Okay.
So in 5 you can be ready to go.
Okay.
We're just about ready for this. That is it. Perfect. Let's see if this. Well, and here we go. Right. Take out a new piece of paper or write it on the bottom of this one because we're going to do another one. Jot this down. We're going to make a whole new set of parallel lines cut by a transversal. Here, by the way, children, if you're wondering if geometry is a math for you, if this doesn't seem so hard or it makes sense or it's like, yeah, that's kind of goes with it, this is what geometry is all about. In geometry, you have to prove things. And this stuff that we wrote down right here is all stuff that you can use to prove it. Like when they say on here, they're going to ask you, they're going to tell you that, what do they say? The measure of angle B is 55 degrees. Angle B. Angle B. How about the measure of angle 8? Angle 8 is 55 degrees. What are the measures? What are angles 1 through 7? And you can't just say it. You have to give the reason why you can say it, the proof that you can say it. And these, when we talked about vertical angles and opposite angles and supplementary and complementary, those are proofs that you can use. And when we talked about transversals cutting two parallel lines, all of those are proofs. Then you have to kind of state them when you do that. So for example, you would tell me that angle, well, we don't have to start with, let's just write them down. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, and angle 7. Those are the 7 angles I have to state what they are. Who can tell me one of those angles and for what given reason? Elijah?
Angle 5 is 55 degrees because it's opposite.
Exactly. Angle 5 is 55 degrees because of vertical angles, or opposite, whatever you want to say. That would be all you have to say. Vertical angles are equal. That's what that whole thing says. So now we know what angle 5 is. Somebody else, Manny Roth, says angle 3 is 55 degrees because to angle 7, exactly, corresponds to angle 7. Now, maybe, oh yeah, no, not yet. Another one, Emily?
Angle 7 is 125 degrees because it's a straight line and it adds up.
And we call that supplementary angles. You have to kind of use the math thing. Supplementary angles. It is a supplement angle 8, so it's 55, so this would have to be 125 degrees. Another one. Isabel?
Angle 6 is 125 degrees, so it's the opposite angle of 7.
Angle 6 is 25 because it is opposite angle 7. Is that true? Another one?
Wait, no.
6 is opposite 7. They're vertical angles.
Would that be exterior right now?
Wait, did we hold on? Did we do something wrong? How come that shouldn't be? Oh, did I draw this all backwards?
Yeah.
Oh, I have my transversal cut in the wrong way. Well, it doesn't matter. It's still true what we're doing. Yeah, I was going to say 8 is not 55 degrees, but my transversal is going that way. It doesn't matter. I mean, it's just, in math, you can't go by what's drawn to scale anyways. You have to go by what they tell you. How about angle 1, angle 2, angle 4? Cameron Colquitt?
Angle 1 is, angle 2 is 55 degrees.
Angle 2 is what?
Wait,
Why?
The-
No, angle 2 isn't 55 degrees.
no. 125 degrees, 125 degrees.
Wait, is angle 3 wrong?
Yeah.
Who told me angle 3? Corresponds to angle 7. But angle 7 was 125 degrees, right? So we should have said 125 degrees. Why did we put 55? Was it me or was it whoever told me that? Sorry. Anyways, where were we at? Angle what? Colquitt, you said 2?
Yeah.
Was what? How many degrees?
Angle 2 is 125 degrees.
Because of?
Because, is complementary, supplementary of angle 2.
Well, we did it. That angle 2 is the one wrong. It can't be supplementary of itself. It'd have to be supplementary to angle 1 or angle 4, neither of which do we have. So you can't use that one. Supplement you can't use because we don't know either one of these just yet. But you can use a couple other ones.
Exterior.
There we go. First person to use it. Angle 2 is an alternate exterior angle to what other angle? What's the other alternate exterior? Yep. This is the alternate exterior, opposite sides of the transversal on the outside side. So you could say that for number 2, it's 125 because of alternate exterior angles. Now we're on a roll. Somebody else who hasn't had a chance to say something. Brianna Massey
Angle what?
is how many degrees?
75.
It's really strange to me now looking at these angles that are. Because of what reason? Okay, it's alternate exterior to angle 8. It is also, for another reason, it also has to be a supplement to angle 2. All of those would be fine. You could say any of those. Alternate exterior. And then number 4, the only one we have left. Luke Franklin, 4 has to be how many degrees?
55 degrees because it's supplement to angle 3.
55 because of supplement to 3. Or it is also a alternate interior angle, or it is also opposite of 1. You got like 4 or 5 different reasons that you can give all of that stuff there. Wow, this really is bizarre. I'm glad I wasn't looking at it when I did it.